Hi, everyone. So welcome to SEC 102 around the Cloud Security Command Center, and also thank you for spending the last part of your day with us. We recognize we're standing between you and drinks, so we'll hopefully keep this interesting. I'm Andy Chang. I'm product manager at Google Security Team and also the product manager for the Cloud Security Command Center. I'm joined here on stage with both partners and customers, and so I'm going to turn it over to some of the other folks.
I'm Michael Capicato. I'm a cloud security architect at 2 Sigma.
Hi, everyone. I'm Kamila Mirova. I'm a solutions engineer and special projects team at CloudFlare.
And I'm Francesco Vigo from Palo Alto Networks. I'm a solution architect on technical integrations.
And each of those folks will be coming back on stage to talk about their parts. And so we're going to kick it off now. So our goal today is to really do 4 things. Talk to you about what an overview of the Cloud Security Command Center is. It's a product we launched to public alpha back in March, and give you an update on where we are with that. Also, to provide, with Michael's help, an example of how 2 Sigma is leveraging the Cloud Security Command Center on their production systems. And then with 2 of our partners, CloudFlare and Palo Alto Networks, how they're integrating with Cloud Security Command Center and providing additional visibility into customers' signals, networking, network traffic, DOS, and WAF. And then I'll summarize. So with the Cloud Security Command Center, our goal really is to provide that canonical place in GCP for you to bring all the things together that you care about when you think about security, risk, and privacy. So it's really where we're bringing together your assets from an inventory standpoint, the detections that you have, the findings, the policies that you're running, the underlying annotations that you want to put especially on the resources. Bring that together so you have a unified view of that, whether those signals come from Google products, from third-party products, from your own detectors. And our goal really is to kind of give back to you visibility and control so that you have the ability to look at your attack surface. So some of the key things that, from a functionality standpoint, the purpose of the Cloud Security Command Center is really to gather and integrate all of that information at an organization level, so you get to look across the different projects and services that you're running. To allow you, as we said, to understand and analyze that information, to act on that information, and really to be a hub for a range of Google security products all in one place. And we recognize that we're not the only player that you're going to have, especially if you're in a hybrid situation. So our goal has been to design this product and this platform as API first, so you can as well egress and export this information to your own systems for further analysis. When we think about the general kind of attacker-defender kill chain, and we see here the attacker kill chain popularized by Lockheed Martin in 2011, at Google we also think about a defender kill chain. And from the defender kill chain side, we think about 2 phases of that. Being proactive in a pre-fail mode, so that you have an assessment of really what your overall attack surface is, what you care about, what you should be focused on, and what matters to you. To really be able to specify ahead of time what are the policies, what are the configurations that you want to run, and also to be able to then monitor the drift against those, and also to deploy protections, things that will, by design, enable you to kind of prevent certain types of attacks and vulnerabilities. We also then think about what happens in post-fail, right? When monitoring logging turn into detection. So the key signals that you find are the ones that you're going to operate on when you're investigating an incident. Obviously alerting on those things so that your teams, your incident response teams, can act on those and your SOC can act on those. To be able to actually then respond, whether it's in a full fix or a mitigation, to then be able to manage your communications across those, and also, very importantly, to learn. And that's learn from a process standpoint, from a people standpoint, as well from a machine learning technology standpoint. The Cloud Security Command Center in V1 is focused on the first half of this chain, being able to enable you to do a much better job of proactive protection by giving you the visibility of those assets and those findings. When we think about how this plays in context, this is a framework that we look at when we think about helping our customers become more secure. So at a high level, we think about the risks that you're looking at really in 5 categories. They're really securing the underlying inventory, and that's the inventory of hardware and software you're running in your systems. Securing the data, that's data that either you've created or data that you've captured from your end customers. Securing the configurations so that each of the services you start off in is in a best practice, known good state, and understanding the drift against that. Securing your identity and access design, management design so that you have the proper amount of access and control to the different permissions and policies, and then helping you secure the applications that you build on our own infrastructure. So matching that are the capabilities we're building into the Cloud Security Command Center, which we'll demo in a few minutes. First is the asset inventory, to give you that view of both the current state and the historical state of assets, the ability to track when assets have changed and how they've been modified, and to really manage those assets and group them in business-relevant ways beyond just what's in the resource hierarchy. In addition, one of the core things and what will be exciting to hear from both 2 Sigma, Cloudflare, and Palo Alto is bringing in signals in to the findings that matter to customers in one place so they can make decisions on that. And then the ability really to provide you as a customer the ability to create filters and queries to find the specific data you want. Obviously, the visibility side is one part, and then the action part is the other. So the ability to mark things so that you can group them by priority, the ability to create notifications through a sidecar application that we ship with the product, the ability as well to do mitigation remediations, again, through a sidecar connection to Cloud Functions. And then finally, to be that hub for the security products like our anomaly detector, our web security scanner, and our DLP technology. So what you'll see in the demo forthcoming is really the UI part of the command center. That UI really has 3 main surfaces. The first is the dashboard, which is really the overall view of what's going on in your system and give you ability to understand and look at what's hot, what's happening, what you should focus on. And then where we see analysts and security professionals spend the most of their time is in the inventories. We have an asset inventory so that you can take an asset-centric view of what's going on in your system, as well as a findings inventory that you can take a findings-centric view. And they both cross-leverage each other. And then finally, for any entity that we've indexed, whether it's an asset, a resource, or a finding, we have the ability to drill in at a detail level so you can look like the underlying properties. So without further ado, I'm going to switch over to the demo. So what you're seeing here now is a live version of the Cloud Security Command Center. It basically is in an organization that we've created. That organization has a bunch of assets. Routes, subnetworks, firewalls, buckets, instances, disks. You can look at it historically, so we can see what changed 7 days ago. So over the last 7 days, we've added a bunch of routes. We've deleted one of the unknown things. We've looked at the firewalls. We've gone and looked at the overall disk pieces. If we go back, say, 3 months, you'll see that the system has even changed more radically over that period of time. And this gives you kind of an ongoing record time series of how your asset state is. In addition, we have the findings side of the world, which is looking at the various signals that are integrated in to tell you what we've collected around either good, bad findings for each of the underlying assets. So first, there's an overall findings summary card, which takes a look at what are the different detectors and what have they surfaced. And then we start with 3 of the Google detectors. So we have a cloud anomaly detector that allows you on a VM basis to understand when we think there's account hijacking going on, when there's potentially coin mining, data exfiltration, potentially if your VM's been compromised and being used in a DOS net, if your VM's been compromised and it's being used to try to intrude on other systems. In addition, we have our web security scanner, which is available in GA and App Engine and is in public alpha for GCE and GKE. And that lets you find things like cross-site scripting vulnerabilities, outdated libraries, mixed content. You can run that on your publicly facing applications, and those results automatically surface in the command center when there are findings. In addition, we're integrated with the DLP technology that we announced, I think, more than a year ago at Next, which allows you to scan all of your public buckets and scan all your buckets in your system, and then classifies whether there is PII found in those buckets. And that gives you a sense of the surface area and the blast radius of when things potentially are compromised, where your data is, what data is highly sensitive. In addition, we're integrated with Forseti. So Forseti is Google's open source effort to build a security community around GCP. And has a set of scanners that both Google has contributed as well as our partners and community members in Forseti have contributed, which those results also index and can be surfaced in Command Center. And then we have a range of partner integrations. From the container security side, CloudFlare, which Camilla will talk about in more detail, folks like CrowdStrike, Dome9, Palo Alto Networks, which Francesco will talk about in more detail, Qualys, Redlock, Sysdig, StackRox, and Twistlock. So that gives you a sense of, and this would obviously be a really unhappy system if all these bad things were happening to it. So as I said, this is that place where customers go on a daily basis to see what's going on. And then if they want to go investigate, they would dig into something like the asset inventory. So the structure of the asset inventory is one that first you can slice your data based on either the projects or the underlying assets. And as we cover App Engine, GCE, GKE, GCR, Docker images, and then GCS from a bucket standpoint currently. And then we'll be continuously adding more of the Google services. You can take that view of either, for example, I want to look at all my buckets. You can just truncate on that. Or instead, if I wanted to go to a particular project, and let's say I want to go to this dev project, and then I wanted to look at just all the buckets that are in that. So I would basically select attribute asset type, type buckets, and then this filters down to just the buckets within that project. So the way we've constructed this is what you select on the left in the kind of overall resource hierarchy. On the right, you get only the assets that belong to that resource hierarchy, and you can further filter things. So one of the things that we can look for, which people care about, is, what if I expose one of my buckets publicly? How would I find that? So first, I would look again, I'd go across my organization. I'd want to go ahead and search again for my buckets. And then once I've searched for my buckets, I'd want to look at one of the properties. And that would be the ACL property. And say, let's say if I have an all authenticated users on that. And sure enough, we have one bucket we've exposed to public, right? So what does that mean? We can dig into that a little bit more. That bucket basically has a set of attributes, set of detailed properties specific to it, and you can see right here that the all authenticated users has been set up as a reader. So if that's intended, that's great. But if that's a bucket with highly sensitive information, that would be bad, and you want to remediate that. The other thing that we want to cover a little bit is from a time standpoint. So if we go back to this demo, this changed at about, let's see, last scan at 3:58. So if we were to look back at yesterday, and we can go back to yesterday, we can figure out whether this bucket was actually public yesterday or not. So as of yesterday, it wasn't. So it happened sometime between now and then, and we can look at then the logs to figure out what that occurred. In addition, from an asset inventory side, we can also slice things based on the findings. So from the findings, first you have, again, two choices. You can see things either listed by all the possible findings, or you can sort them by the particular source type. And so we have findings from each of the underlying sources. If we were to dig into a finding, let's say our own anomaly detector, we could find and dig into the VM that has coin mining, and what that ends up telling, again, on our detail page is what action should be taken against that, what it's against, and it's an active finding, and the underlying summary of what's going on. For third parties like CloudFlare or Palo Alto, when we have an integration there, they surface their findings as a summary, just like any other finding. You can drill into that finding. They provide underlying detail. And then you can connect back to the partner console. So go back into the CloudFlare system in this example, look at the particular website that's involved, and then dig into the underlying data there as well. So that's the kind of integrations that we have with the underlying providers. So to wrap up this part of the demo, what we've covered today really is some of the underlying capabilities for filtering and searching. One last thing we have the ability to do is for you to create marks. And what those marks allow you to do is to group data by things that matter. So, for example, I created a mark previously around an incident. And I care about all the different findings that are relative to that incident. So I've already pre-marked them, so that becomes these 8 or 9 findings. And similarly, on the asset side, I've also put that mark together on some of the assets that are relevant to this. And so as we go ahead and then put the same incident number in, it pre-filters down to those, and then I can go in the dashboard and again look and see just for the assets that are relevant to that incident as well as the findings that are relevant to that incident. So with this, I'm going to switch back to the slides. And so what we covered there was the asset inventory, the findings, the ability to filter and search, and the ability to use the marks, and also the integrations with a range of our partners. What we now want to talk about is, as one of the core parts in the differentiation for Command Center is the ability to integrate all those findings. So we're going to dig a little bit deeper into what that means, what findings are, what finding sources are. So for us, we've defined findings very broadly. They really are an output from a source, and it could be a curated output, could be a raw output, that then applies to an asset that we've indexed or a resource that we've indexed. And that allows us to build that connection to do either a finding-centric view of the world or an asset-centric view of the world. And it's valid for a particular time or between 2 time points. So that allows us to tie that into its history and its life cycle. And they need to have a unique ID because we automatically dedupe findings within Command Center. So if you have the same finding 6 or 7 times, it doesn't show up as 6 or 7 findings, it shows up as the same finding, and it just updates its properties and its timestamp as it goes. And so that allows things to be correctly indexed and joined in the Command Center database. When we think about findings, they come from finding sources. And our mental model so far for finding sources is really around the ability to think of 3 main types. Scanners, which really provide you essentially a snapshot in time of the state of your whole system, or the state between 2 time points. And what that allows us to do is to say that represents the kind of complete state that we want to integrate in and see what's going on for that timestamp. Examples of scanners are the Cloud Security Scanner that we've integrated within Google, the DLP scanner as well. They both scan the state of either an application or a set of buckets at a point in time. The standard L3, L4 network scanners that are scanning ports, because again, they have an overall scan across a set of ports, they have underlying results. Things from container image scanners from folks like Twistlock. And the second type of finding source that we integrate with are monitors. And so those are things that produce event streams. So the common example of that are agents that are put into either VMs or into containers, and they prevent basically a stream of events with no history back to the system. And the third type of source that we integrate with are really loggers. So that's the canonical log file ingestion, where that's a series and historical record of a series of events that get ingested and processed. So if you as a customer or you as a partner have one or more of these types, these are types that we can integrate in and have their results joined together with the rest of the findings in Cloud Security Command Center. Think a little bit more about how that happens. What we show here is a screenshot of our Alpha API. It's a little hard to read. There's a link directly to our documentation, which is it's a public documentation of how you use the Create Findings API. The key thing is that there are really 7 things that you need to provide as someone who wants to write results to our Command Center. The first, as we talked about, is that unique ID, so that we can do our own deduping. The second is the actual insight that you want to surface in Command Center, both in the dashboard and as kind of the key title in indexing for the findings inventory. The third thing is the mapping to the 1 or more Google Cloud assets that these findings apply to. And the fourth thing is a timestamp. So as we're a historical record, we're able to put that finding in place relative to the other things in our time database. And then lastly, the link back to, if you're a commercial vendor, your own portal. Because our goal and our philosophy with integration is to really surface the key things that we think are relevant to the customer. But if they want to go in deep and dive in more detail, we fully expect that they'd want to go into your own dashboard and explore those using the tools that you've invested in. So that linkage, as we showed with the Cloudflare example, provides that two-way kind of transition. And then lastly, the key thing to add is the finding specific properties. So when you surface a finding in your side as either a customer or as a partner, identifying the key items that you want the end customer to see that will drive them to an action that will help them get to a more secure space. What partners get from integrating with the Cloud Security Command Center and what they gain are really showing up in 4 key places. First, in the summary on the dashboard, as we saw with each of the dashboard cards. Second, in the inventories, both actually in the findings inventory and in the asset inventory, because the assets can index into the findings. Into the specific detail pages, which allow the customer to drive action. And then actually into our Data Cube index, which is our back-end database, which allows you to search, select, and find the API and the views. If we think about integration, there's really 3 options if you're a customer or a partner of how you can integrate data into the Cloud Security Command Center. The first option assumes that you have a presence in GCP itself. And so, in this model, as a customer, the customer has an organization in GCP, you have an organization in GCP. The first step is for you to essentially scan the customer's instance or instances or organization so that you find out what's going on. The second is to spin up a connector project in your own organization, which will end up being the intermediary between your overall backend and our Cloud Security Command Center. The third is to do then the authorization so that your service account for your project is authorized to write the Security Command Center of the customers, as well as you do your own authorization to your own backend to uniquely identify the customer's information that you want to send, and then to push the data from your backend into the Cloud Security Command Center via that connector project. The second option is if you're not running on GCP at all, is to instantiate your connector project after you do the scanning in the customer's organization. So to provide the basic underlying code that allows the customer to stand up that connection point. Again, authorization both towards us and the customer's Cloud Security Command Center, as well as to your own back end so the right data gets to the right place, and then connecting the data through and through. And the third option is if you're not running anything on GCP and you have completely partner backend, is again to first scan the customer's information or organization for the results that you want to run. And then through the customer, allow them to authenticate into your system, provide an API key that gives them access to the command center. And once that API key is installed on your back end, you can then write to the Security Command Center specific to that organization. So those are 3 methods. We've had customers and partners use each of these 3 methods to do integration. And if you want to find out more information, please find me after the talk. So to summarize the kind of first part of the Cloud Security Command Center is, at the end of the day, the goal is to integrate in one place and unify our assets, the resources, and findings. If you want to integrate your findings in the Command Center, our kind of partner model is really set up in 3 stages. First, a scenario definition between the product managers so that collectively we're looking at the end customer's journey so that the right set of data gets surfaced in Command Center and the right pull and kind of pull through occurs to drive them back to your own console. Prototyping, so that we build an example first within a demo organization that us and the partner manage, and then find a lead customer to kind of go deploy that live with. And then finally, the execution deployment at scale for general availability for customers. So with that, I've kind of given you an overview of both the capabilities of Cloud Command Center as well as how partners integrate with Command Center. What I'd like to do now is to turn this over to Michael Capicato from 2 Sigma, talk to you a little bit about how they've used Cloud Security Command Center.
My name's Michael Capicato. I'm a cloud security architect at 2 Sigma. And I kind of wanted to introduce who 2 Sigma is, what we do, and a little bit about how we approach cloud security before I show you what we're doing with the Security Command Center. So 2 Sigma is a New York City-based hedge fund. We use things like artificial intelligence, machine learning, distributed computing, all of kind of the latest technologies to drive our investment strategy. And for that reason, operating in the public cloud has been extremely important to us so that we can scale up and scale down very dynamically. To give you an example, we use something like 35 petabytes of data to build our investment models, and this is a growing number. And so one of the primary concerns we have in cloud security is really protecting against data exfiltration. So all of the code and data that we write and generate, it's very important for us to protect against this leaking, right? That's our job. So that's the approach we take. And we really think about it in 3 ways, right? We use defense in depth so that we have a layered approach to security. If we kind of make a mistake in one area, we can fall back on other areas. We use automation very heavily, right? As the public cloud has moved, I guess as we've moved into the public cloud, we've seen things scale up a lot quicker, right? People can procure VMs in a few seconds as opposed to like a few months. And so obviously the attack surface scales very quickly. And this means that we have to react quickly. So we use automation from a security perspective for things like secure approval and deployment pipelines, very repeatable security processes. And then of course, there's like the continuous audit piece. And that's extremely important to us because even though you set up your environment in a secure manner on day 1, 6 months later or 2 years later, it's going to drift, right? The configuration and the environment's going to change. And so you want to have some sort of system that's continuously auditing your environment to kind of have control over what's going on and to react to any changes. So just to talk a little bit more about defense in depth, if you think all the way up at a very high level, you have like your organization in GCP, and you can apply something like an organization policy. What this does, just to give you an example, is it's really like a blanket security control on your whole org. So one example of how we use that is we build like a secure image, say a secure Debian image, with all of the security controls and OS hardening kind of mechanisms that we use. And then we apply an org policy that says, in any of the folders or projects that 2 Sigma has, we want users to only be spinning up VMs from that secure image, right? So that's kind of all the way at the top of the stack. Bubbling down a little bit into the individual folders and projects, we create custom IAM roles for our users and groups. And we do this based on a least permissive model, right? So only the kind of minimum set of permissions those users need to operate successfully in their environment. We create a custom role and assign it to them. Things like VPC security controls to kind of draw a secure boundary around all of our resources. And then all the way down to the individual resource level. So if you think about like BigQuery data sets, you can have access control lists on those actual data sets. Another example is a GCS bucket, which I'm going to be using in the demo. So those both have concept of access control lists, and you can control the security at the individual resource level, right? And then speaking a little bit more about the automation we use, there's some, I guess, unexpected consequences of using certain GCP APIs. So to give you an example of that, if you authorize your users to create a data set in BigQuery, when they create that data set, they actually become the owner on the data set access control list. And the consequence of that is they can turn around and share that data set, even with users outside your organization. Right, so for us, this is like a huge shock because we're trying to prevent data leakage, and obviously we can't have like sensitive data loaded into a data set and then just any user can share that with the world. So an example of how we use automation to fix that is we've actually written a serverless cloud function that creates data sets on behalf of users. And so they call that cloud function. The cloud function creates the data set, and it strips all of the owners out of the ACL, kind of fixes it up. And then it returns back to the user, here's your new data set, you can use it at this link. And really the last piece is, even though we've taken an approach that uses defense in depth, that uses automation, that's really kind of the day 1 setup of the environment, and it drifts over time. So we use, in conjunction, Cloud Security Command Center and Forseti really to monitor our environment, to audit, and ensure that those security guardrails are still in place, and then to surface any violations of that to us. So I'm just curious, show of hands, how many people are familiar with Forseti? Awesome, cool. Okay, so 2 Sigma is a contributor to Forseti, and I encourage you guys to become contributors if you're interested. Working with the Cloud Security Command Center and Forseti teams has been extremely positive. They've been super helpful. And we've been able to contribute some code to Forseti and to get that merged into the latest branch. So I'll talk a little bit about that later. But for those of you who haven't used Forseti or heard of Forseti, it's really a tool that lets you scan your environment, and you can write very simple rule sets in YAML format. As an example, if we keep using this BigQuery example, you could write a rule that says, I don't want any @2sigma.com users in my dataset ACL, ever. And Forseti will run periodically. It will scan through all of your data sets, and it will find violations of that rule. And you can surface those in various ways. You can get an email to yourself. I know they're building out integration with PubSub and Slack. But of course, we use Cloud Security Command Center as kind of our central pane of glass. And so we wanted to surface commands into there. And that's possible today with Forseti. There's integration between the two. So let me walk you through a little bit of an example. This is kind of what I'm going to demo, but I just wanted to show you guys what happens first, right? So it's very similar to the BigQuery example. So let's say you have a user, Bob. He joins your company, and he wants to create a bucket. So he's going to install the Google command line utility, and he's going to make a simple API call to create that bucket. And the unintended consequence of this is in the back end, the data set has an access control list. And Bob just became owner on that bucket, and he can now share it, right? And if you're trying to protect buckets and make sure that they don't get shared outside of your organization, this is kind of an undesirable effect, right? So yeah, bucket owner equals Bob. Owners can share. I kind of already explained that. This opens up a very easy path for data leakage. So what we would do, I guess, if we were thinking about things from a very manual perspective, as a diligent security team, we would want to go modify the ACL on that bucket, right? And of course, there's like an API call to do that. So we could install the command line utility and say, I want to change the ACL on the bucket, and I want to set Bob to be an editor and not an owner. But you can imagine that as your organization scales and there's hundreds or thousands or tens of thousands of users all creating buckets, you're not going to hire 100 people on your security team to constantly go change the ACL on all of the buckets, right? So what you would probably do in that scenario is you would abstract it away with a cloud function or something like that, like I explained before. But that's kind of only the initial setup. That means that when the bucket gets created, you're going to remove unintended owners from the ACL. It doesn't mean that it's going to stay that way forever, right? And there's always going to be like super users in your organization that can go and make changes, whether maliciously or just by mistake. So this is where Cloud Security Command Center really helps us. Andy talked a little bit about the security marks that you can apply. So we use these in a bit of a different way. We mark resources in Security Command Center with a security level, right? So it could be like open, internal, restricted, super, super restricted. And what we do is we use these marks to differentiate resources, and we can apply scanning to only certain classes of resources that we care about. So let's just walk through that, right? What we would do, rather than creating buckets on behalf of the users, is we would create that security mark. And in this case, we're just saying the buckets that we care about are restricted. They have a security level of restricted. And now let's say that someone makes a mistake and they add Alice as like an owner on that bucket ACL. We have some very simple code that we run on a periodic basis, and you could run this in a cloud function, you could run this in App Engine, you could just run this on a VM if you're not familiar with those services. And what that code does is it will go reach out to Cloud Security Command Center and will say, give me a list of all of my resources, all of my assets that are security level restricted. And if any of them have kind of unintended changes, like say the bucket ACL has been changed in the past 10 minutes or 24 hours, create a finding. Create a finding on that asset in Security Command Center so that the incident response team can go and take a look at that and kind of fix it. So I'll show you a simple demo now. We'll switch over to the demo. Awesome. So I've got this bucket here called Next18 Demo, and you can see on the, can everyone see that, or should I zoom in? Zoom in a little bit. Right, so it's got a security level of restricted. If I just dive into it, you'll see here it's marked as restricted, and right now there's 14 findings. Now I want to point out we hope to see more findings if the demo is successful. Those 14 are for me testing it so that I could make sure it worked for you all. So Right, so we've got that bucket. It's got 14 findings right now. And the thing we care about is whether or not the ACL has changed in whatever time period we've defined. So what I'm going to do is I'm going to go over to the actual bucket here. And in the console, you can actually edit the permissions of the bucket. And this is how the access control list on the bucket gets controlled. So what I'm going to do is I'm going to add myself. And I'm just going to pick something random, like, say, storage legacy bucket owner. Awesome. So you can see I've added myself to the bucket ACL. So the ACL should have changed now. And what I'm going to do is I'm going to just rescan all of our assets in Cloud Security Command Center. This should take about a minute or two. So while this is running, I'm just going to walk you guys through the code, a little bit of the code. And today we're running this on like an hourly basis, but we could speed this up if we wanted to. And I guess it's worth pointing out that, you know, initially Cloud Security Command Center only had like a REST API exposed, but now there's a Python client library. So for those of you who are like familiar with Python, it's very simple to interact with Security Command Center and write some simple code that interacts with it basically. Right, so I've got this method here called check changes. And this is very simple. All it's going to do is it's going to take a start time of 15 minutes ago and an end time of now. And it's going to say, in that 15-minute window, get all of the assets from Security Command Center that have a security level of restricted mark on them. And if any of them have changes that we care about, create a finding, right? So there's another method called find changes. And this makes a call out to Security Command Center, get assets by mark. So it's one of the API methods you can use. You can retrieve all of the assets from Security Command Center that have a certain mark. And of course, for different assets, you're going to care about different things, right? For a bucket, we care about the ACL and the owners on the bucket. But for something like an instance or a firewall, you might care about different properties. So we just have a simple if statement here that says for all of the assets that come back, sort them by type. And if it's a bucket, in this case, it's the only one we're checking in this demo, we go into this method here, bucket changes. And so what we then do is we make another call to Cloud Security Command Center, and we get the final asset. So we have the asset representation at the beginning of the 15-minute window, and then at the end of the 15-minute window. And we compare those two. So here's the one we're kind of interested in. We say, if the initial asset's ACL is different than the final asset's ACL, then just call out to Security Command Center and create a finding that says the bucket ACL has changed. And I'll show you how simple it is to actually create that finding. So this is, that was all like kind of my custom logic code and stuff. This method here, which is probably about 5 lines of code, is creating a finding in Cloud Security Command Center. So that's really all you need, right? We generate a unique ID for the finding. We specify the category. We specify the source and an arbitrary JSON blob of properties. And then just the asset that we want to create the finding on. So in this case, it's a bucket. So I'll actually run the demo now. We'll hope it works. So it scanned through a bunch of buckets, and you can see there for the next 18 demo bucket, which is the one that I just changed, it found 2 things, and it sent them to Cloud SCC. So if we go back to the console now, and I'll just update this to now, we should see not just 14 there, right? So we can see now there's 16 findings, right? So the default object ACL and the bucket ACL both changed. This was like 5:15 just a couple minutes ago. And yeah, that's really it. So what we do is we basically run this code, and we've extended it since then to look at different things, not just buckets and their ACLs. And we run this just on a VM today, and it wakes up every so often, runs, surfaces findings to us, and then we react to them, basically. So we'll flip back to the slides. Awesome. So I wanted to talk just a little bit before I get off stage about Cloud Security Command Center and Forseti and the integration between the two. So when we first got exposed to these two services, the way it worked is Forseti would basically construct a list of violations that it found based on all the rules that we had written, and it would push these to a GCS bucket. And then Cloud Security Command Center would reach out to that GCS bucket, it would parse all of the violations, and it would load them into findings. We thought this was like a little bit clunky. It was the only thing available at the time. But then, one day Andy and I were talking, and the API for Cloud Security Command Center had been exposed. And so we thought, why not make this a little bit better? So what we did is we worked kind of closely with the Forseti and the Cloud Security Command Center teams, and we modified that code so that we used the Security Command Center API directly. So for any of you who are using Forseti today, you'll be familiar with like a YAML file that you configure Forseti with. You tell it like what notifiers you want to run, what rules you want to run in the scanner. There's a new section, and where you enabled the Cloud Security Command Center integration before, you can now say either use the bucket mode or the API mode. And if you set it to API mode, it's going to use the API directly rather than using that GCS method of writing to a bucket. And there was really like a couple of reasons why we wanted to do this. One was obviously it's just cleaner to use the API directly and not have to rely on that like latency of writing something to GCS and then waiting for it to be read. But the other reason is we have a lot more control now within the Forseti code base to publish whatever properties we want directly into that finding in Cloud Security Command Center. So based on the rules that your scanner is using, you can write different property fields into Cloud Security Command Center. All right, so that's it for me. I have a wrapping up slide here. Not much for me to talk about, but really I just wanted to link to the GitHub code base there so you could see kind of the integration between the two services. And I encourage you guys to play around with it. So thank you, and I'll invite Camilla from CloudFlare up now.
One more time, hello everyone. I hope everybody can hear me well. Just give me a second. All right. So, those of you who haven't heard about CloudFlare, which is not a big surprise, we probably one of the largest internet companies you might maybe not aware of, but you have used us today. Everyone in this room would have gone to one of our millions websites, properties, APIs, applications that actually been protected and accelerated by CloudFlare. In fact, every single person which uses internet today touches our network every week. Our mission is to build a better internet. So where are we today? You can see it on the slides that we build a massive network. We have over 150 data centers globally, and the number is growing. More points of presence means that we create less latency for websites and applications and APIs to be reached, but it also helps us to mitigate really large attacks, DDoS attacks. We handle about 10% of the global HTTP traffic, and our network capacity about 15 terabits per second. Currently, we actually have about 8 million applications, websites, and APIs that use us. Well, this slide helps you to understand where CloudFlare stands with Google Cloud. We're not just the partners. Google also our investor. As CloudFlare, we refer to ourselves as an edge network provider. So those of you who know, or what is actually edge? Edge is where you meet the business in the internet, or in the internet. Originally, if you might remember, there was once you open your web browser or application on your phone, you are connected directly to the service, which is actually used for that business. But we become extremely demanding in terms of performance, reliability, and of course, security. We expect walking down on the street, having our phone with us, order a taxi, and almost immediately see where is it on the map location. We expect walking down on the street and FaceTime our parents or families in a high definition and being actually everywhere on the globe. So in order to achieve this, a new layer has been introduced in the internet. This is what is called edge. And this is where you are connecting to business today, and this is where CloudFlare sits. Speaking about the security aspects and be efficient in it, many companies facing the following challenges. Let's take, for example, a real use case of a customer, which is one of our customers' online video platform with running classes on internet around the globe. They have infrastructure with using multiple clouds and also something on-premise. Like imagine to maintain and manage the whole security policy and security aspects for all that heavy, sophisticated environment. The challenges, first of all, is that it's all different tools to use, all the different interfaces. The way too many way how you can get that information, but you have to know each tool separately to evaluate this information by yourself, or run a special script to get that information gathered in one place so you can finally analyze it. Or another case, in our case, for example, our customers, they see information that's happening on their data centers on the server, which is running on, for example, Google Cloud Platform, but also what's happening on the edge. But they don't have an option where to see that things together. And this is where Google Cloud Common Security Center plays actually a very powerful role. It gives a simple interface where you are able, within the same unified dashboard, to see that data that coming also from the edge and as well as from your actually servers that is running on. CloudFlare built an integration with Cloud Security Common Center to extend actually security from data center all the way to the edge. And CloudFlare dashboard, actually Google Cloud Common Security dashboard, as you can see it here, being populated with a firewall, web application firewall, and IP firewall events that actually are running in a real time that help you to understand what's happening right now on the edge with your services. So let's take a look a little bit at the solution in more details and how actually works the integration itself. The first step, we're going through the Google Cloud Platform. I'm going to use the thing. Yeah, with a simple click of a button, the customer, like Two Sigma or any other customer, creates an instance of App Engine, and while it's created, it also generates a unique public key URL that will be used on CloudFlare side to encrypt the data to send them to Google Cloud Platform App Engine API. So all communication is happening over SSL. So let's move on CloudFlare side to see what's happening on our edge. In this case, in CloudFlare UI, customer uses JavaScript, which is run within the edge workers. So now you ask me, what is actually edge workers? So while we maintaining security and performance aspects for our customers, CloudFlare introduced an additional functionality, CloudFlare Edge Workers, which allows you to run the code on the edge instead of your server. So which immediately reveals a powerful functionality and web extensibility by moving your logic from the server all the way to the edge, which means you can run A/B testing now, you can decide which traffic you want to face it and test it and load balancing it, also improving user experience. That everything now can run on the edge instead of like creating that latency to get the compute and calculations on your server and goes back and again. So that's a huge advantage. So in this current integration, as you can see, this edge worker acts like a proxy, actually a very powerful proxy. What it does, it actually connects via API to CloudFlare API to download the logs, which is actually gathered from all our 150 data centers, and send it back to Edge Worker, where Edge Worker encrypts its data with public key that we got generated in App Engine instance and send it to Google Cloud Platform, where App Engine instance get this data and post it through Cloud SCC API to Cloud Common Security Center dashboard. So it runs quite fast, and also very important that on top of all that functionality, we very care about security point, and this is very important that both systems, they won't expose their sensitive data. So private API key that's used by edge workers to download the data from Cloudflare edges remains within the system, as well as Google Cloud data as well. On top of that, we have improved security by allowing to lock requests coming to Cloudflare Edge only from Google ASN number. Or you can also set up a rate limiting so that you know that it has that extra security levels. All right, now let's, with that saying, dive into demo. If you could switch the demo, please. All right, so I prepared a small example here. The website is called usualwebsite.com. In this case, we're gonna run it on a real use case. Let's say I'm an e-commerce site. I'm actually selling Argentinian wines. Actually, I love Malbec, so no secrets. And I wanna make sure that I'm protected and I'm benefiting from performance and also able to see everything that's happening both on data center and the edge from security standpoint. So let's switch to the Google Cloud interface, and this is where my website is a simple WordPress site that is actually being built on App Engine that's running on the demo target project. That's where it's actually been serving. And as a separate project on the Security Center API project, I actually made an installation of App Engine that talks to Cloudflare Edge workers. So now I'm going to switch to Cloudflare UI to get you understand what's happening here in Cloudflare UI. As well as you managing all your DNS security performance settings, you also have here workers section. So I'm going to launch an editor. The way Cloudflare workers work, it's using actually different JavaScript. So that's the JavaScript that adapted for your needs and using your own credentials. You can see it here. If you might recall, the public URL that's going to be encrypted, that's the one that's going to be used by the worker, and all you need is just to hit the button save, because it's already have that information filled out. You can see it here. Org ID, API key, and everything just stored within this Edge workers, which never leaves Cloudflare Edge. So once we push the data, it actually ends up in Security Command Center. And I'm going to now a little bit to make it small so that you can see what's actually happening. Within the dashboard, as other companies, we have a CloudFlare Card where you can see, let's say, a quick glance of statistics that's actually happening on your edge. You can see the top threat origins, the percentage of them as well. And you can see the type of threats we've been seeing, like a firewall, IP rate limiting, and what the last seen events in the couple, let's say if it's a minute or hours, something that hit our edge. So if you want to look at each of them in details, we just click on the card or we just click on the findings, and on the Cloudflare, we do have a list of events that being captured and populated here. So let's have a look at one of them. In this event, what it can tell us? It can tell us that it's actually IP rate limiting exceeded. You can see actually the asset ID, which one going to be used in this case, and scanner ID, which is Cloudflare in this case, when it happened, and the timestamp. Very important, that's something that is very, allows you in Cloud Security Center, go back in time, so you can look at, you can filter it upon that request or events that you are interested in. It also helps you to identify which VM or which app engine or container is actually happening on right now. So let me find another very quick event that I can give you idea of what extra information you can see it here. Yeah, probably just gonna do it here. Yeah, for example, SQL probing. Yeah, in this, it shows you the organization. It shows you the information about what the request method it was, what the host name, the country, and other external informations. So if you want to make any changes, you still need to log in through the partner link to CloudFlare UI and let's say block this IP or block the country or challenge it very easily. All right, that's actually all for the demo, and I'm going to hand over the talk to Francesco from Palo Alto Networks.
I'm actually starting with the demo. It's not really the demo, but I just got an email from a friend, and I wanted to start. Can you switch to demo 2? Yeah. So I got this email about a super fast Bitcoin miner, which sounds interesting, right? So I want to actually start mining right now on this cloud machine so I can get rich. Maybe I can pay for some drinks later on. So let me download this one. Copy on the desktop. This is a machine running in the cloud.
Can you send it to all of us?
I will see. I mean, let me try that. I think it's a good idea, right, to do this on the cloud, right? So let's do it. Oh, okay, it's been blocked by traps, our endpoint protection. So it wasn't really a good idea. Unfortunately, nobody's watching, right? Nobody's recording, right? My boss is not in the room. Oh, he is. Okay, forget about that. Let's switch to the slides for a second. So how many of you know Palo Alto Networks? Okay, quite a few. So our mission is protecting the digital way of life of our customers. And I'm not explaining exactly what we do with all the products and features, but what we call security operating platform is a set of solutions running on network as firewalls, endpoint, cloud protection, virtual firewalls running in the cloud, and so on, that is meant to successfully prevent cyber attacks. That's what we do. And one of the reasons we have been so successful and we grew so much is because we allow our customers to consume innovation, and we allow our customers to integrate our solutions with their own solutions and with third-party solutions. That's very important. The automation and integration for us is really a key part of our success. And one of the things we are working on right now, which is not available yet but will be soon, is something that we call application framework. And again, I don't want to get into too many details. You can come to our booth and ask our questions to us. But the point is, many of our customers have firewalls running in their network, are using our endpoint protection solutions, are using our cloud protection solutions, are running virtual firewalls on GCP. So for the customers that want to do so, they can actually send all the logs, all the data from these devices, like security logs, security-related data, to our cloud. And by doing that, they enable us to run advanced analytics on top of that. So we have some solutions called Wildfire, Magnifier, and so on that can actually do threat intelligence, do user behavior analytics on top of the data that our devices and endpoint solutions put in the data lake. And this has been working for a while. So with App Framework, we're adding something more on top of that, which is providing third parties a way. So third parties means partners, other vendors, could be even competitors if they want to do so, and customers as well, providing APIs to access the data that is present in the application framework. So as a customer, if you consent so, you can give access to your security data that was gathered from Palo Alto Networks and is stored in the Palo Alto Networks cloud to a third-party solution. And through APIs, these third-party solutions can integrate and do analytics, do remediation, do threat intel. There are lots of use cases. And again, vendors and customers will be able to do this. And why we think this is important? We think that this is important because if you look at the security consumption model, how many security vendors are out there? A lot. And each single security vendor provides some unique value to customers. The problem is that if you want to try one of those vendors, one of those solutions, or if you just want to build a solution because you are a vendor, you want to build a solution that does analytics, for example, you will need to deploy sensors, deploy agents as a customer, and as a vendor, you need to write sensors, write agents, but your core business is really analytics maybe, or threat intel. You don't really need to build that stuff, but you need that in order for your customers to consume your unique value, right? And for customers, it's painful to do these POCs. They're long and complex. The other problem is that if you have lots of security solutions, you have to deploy lots of things, infrastructure cost, operations cost. It's hard to manage. And lastly, integrating all these different data sources and providing an effective automation workflow that protects the customer is hard. So with something like application framework, we want to be the sensors and enforcer in the network, in the endpoint, in the cloud, and allow, again, third parties and customers to leverage our data to do analytics. So if you want to try a third-party solution, you can just grant them access to your data as a customer, and they're ready to go. If you're a vendor, you want to build a solution that integrates with that framework, you don't need to deploy and create sensors and agents. You just call our APIs. So this is very effective, and you don't need to reinvent the wheel every time. And the automation capabilities that we can bring there are very interesting. In fact, when we started working on this, we were thinking about some use cases. And the more we work with different partners and different customers, we learn additional use cases that we didn't even think about. So that's really exciting. So this is what we're doing right now. And back to the Security Command Center integration point. Back to slides. Okay. So what we did is building an integration between the application framework and the Security Command Center. It's a simple application. We build it using serverless components. We use the Python SDK as well. That was pretty easy to do. And the idea is that the data is coming from Traps, our endpoint solution, from the firewalls running in GCP. All this data is flowing in application framework. And from there, the Security Command Center app is able to pick the data up and generate findings into Security Command Center. And through some user interface, you can actually enrich those findings with TI data. You can act upon that data, providing blocking and remediation on the firewalls, potentially enable third-party integrations on top of that as well. So this will become clear in a second. So what we are doing right now is showing this flow. So on the bottom, you have an endpoint, which actually is the machine where I try to Bitcoin mine, that had a malware that was blocked by our endpoint protection Traps. And the logs are being sent from the endpoint to application framework. This will actually be stored there, and the Security Command Center app that we wrote will pick up this data, detect that there is an alert, and create a finding in Security Command Center. So we will see a finding there, hopefully. And from there, we will open another console that we wrote, again, for the purpose of this integration, very simple, where we can do additional analytics, look at additional data, and enrich that alert with threat intel information that we have, and eventually block the associated command and control IP addresses on the firewalls, so protecting the other machines that are running in the cloud. And if for some reason there is some machine that actually has been infected by that malware because maybe my colleague wasn't that smart and he didn't install Traps on it, the firewall will now block it and will tell us that something is going on, and we'll see additional alerts in Security Command Center.
What you do before click? Like,
You can do, so the question is, can you do the enrichment before creating the alert? Yes, you could. So the idea is we are doing that manually. So as a security analyst, I decide that I want to enrich the data because I think that this is an important alert that I want to enrich. But obviously, you could change the workflow and automate that and add threat intel before creating the alert. So let me go to the demo. OK, thank you. So this is the dashboard. There are 2 alerts. Now I refresh. And I see 3 alerts, which means that it's working, which is wonderful because this is an alpha product from Google. It's a staging environment alpha for us as well. And our DevOps teams did some deployment today. So I'm lucky. So if I look at the details of the finding, you will see that we have some stuff in here, and one is called Traps Wildfire Malware. So this specific finding was generated, you see on top, 8 minutes ago when I actually tried to block, I tried to run the Bitcoin miner, and that was blocked by Traps. And I have lots of information here. The user that did this, Francesco, the IP address of the machine that generated that, the malware hash. And something interesting also is that this is linked to the asset in Google Cloud. And this is important because Traps doesn't know anything about the fact that that's an asset from Google Cloud. It just knows the IP address. And we used actually the API provided by Security Command Center to ask, in our organization, which machine had this IP address at this point in time when this event happened, and their API said, Win Server 1. Good, so we add it here. So this is the event as we see it, and now I can open the partner console, which is, again, simple application that we wrote. Right now I'm pulling additional traffic and threat logs related to that machine from the application framework. So I have firewall logs and other stuff that I can pull and visualize here. And again, I don't want to get into too many details, but one of the things I can do is, this is suspicious, right? So let's see if Palo Alto Networks knows something about threat intel, some threat intel about this specific piece of malware. So when I click on autofocus, I'm calling again our cloud APIs, and I'm pulling threat intel information from our cloud. And if you see these tags, well, I'm not getting into the details of which one of that means, but basically it's telling me that this is a specific piece of malware that is part of a specific campaign, and there are some IP addresses and FUDNs that are associated to this specific piece of malware. I would probably want to block this. Before I do that, let me switch back to the Security Command Center console. So by doing that, we actually added those autofocus tags marks in the security event. So this means that even if I don't have access to the other console, I just have access to Security Command Center, the fact that myself as an analyst did that enrichment, this information becomes available also to my colleagues when they look at this specific finding. So back to our console, I want to block this. I want to block the associated command and control IP address. So what I'm going to do is just click on block, but before doing that, let me switch over to the firewall. Again, I don't want to get into the details on how this works, but this is our firewall running in GCP. I created a policy that will block all the IP addresses that are part of a specific dynamic address group, or DAG. And right now, this group is empty. So there is nothing there. If I go back to my UI and click on block, through application framework, we are telling the firewall, OK, from now on, you should block the command and control IP address associated to this malware. So if I'm lucky and get back here, OK, you see in the firewall, that IP address is now being blocked. And this information, again, is also reflected in here in Security Command Center as an additional mark. So again, as a fellow analyst, I can look into this and say, OK, someone took care of this. This should be good enough. So I can actually do a resolve here, saying, OK, this incident has been taken care of. So I just click resolve. And if I go back to Security Command Center, this will now disappear. Why? Because this will be marked as resolved, and I have having a filter here that is showing only the alerts and the findings that are not resolved. So one last thing I want to show you is that now that I actually set the block on the firewall, I might want to see if there are other, again, there is other activity related to that specific command and control for that malware. And actually there is. So my colleague is actually has a machine that is actually trying to connect to that command and control, and that was blocked now. And this is, again, something that I can see on the firewall, but also through the integration with application framework. And this might take a few seconds to show up because, again, the log is going to application framework, and the application that we wrote is pulling the data from application framework and generating the finding in Security Command Center. So let's wait. few seconds if we have them. I mean, the last bit of the last demo of the last presentation of the day. Obviously, there is some suspense, right? Here we go. So C2 traffic blocked. Again, this is another machine. This alert is still coming from application framework, but originally has been created by the firewall, not by the endpoint agent, but the user experience is exactly the same. And we have different user and other information. So the previous incident has been resolved, but I have another incident I should work on. So that's all I had for the demo. Let's go back to the slides one more time, please. Thank you. So takeaways. First of all, it was fun and easy to integrate with Security Command Center. We had a great, again, Python libraries were easy. Serverless was pretty good to work with. And Andy was great in supporting us. And the other takeaway is that with application framework, we encourage vendors, competitors, customers to come to us, talk to us, and build applications that can leverage the data we provide in order to provide value to yourselves or to your customers. Please reach out to us. Because again, you can easily get access to the Palo Alto Networks data if your customers allow you to do so, of course. And with this specific integration, we were able to build a simple single pane of glass through Security Command Center. So that's all I've got. I'm inviting Andy back on stage for the wrap-up.
Thanks, Francesco. So thank you so much. I think first give a round of applause to all the speakers who did live demos. We were 4 for 4, so a little bit of bravery there. I think to quickly wrap up, because I know we're towards the end of the day, some key questions that the Cloud Security Command Center has helped answer for customers are around the assets. A fundamental question is, what do I have? What am I running? I think our experience has been that with the shadow IT that develops around cloud, we actually provide this visibility to customers. Customers have sometimes been very surprised. The average amount our customers are off is about 25%. Some customers were off by a factor of 3 as to how many assets they were actually running in cloud. So that core visibility is one of the first things they gained from this. As we saw with Two Sigma, CloudFlare, and Palo Alto, the ability to integrate findings from a lot of different places to get really at things that are going wrong, potential risks and vulnerabilities in the cloud, has another been a huge win. In addition, with our own detectors in cloud anomaly detection, the security scanning, and the DLP, it's given further visibility to our customers as to what's going on in their systems around the finding pieces. And as you can see from the slide, and going back to the original slide about what we're building Command Center to try to help you detect, it's issues around your inventory, around your config, around access, around data, and around the underlying applications you're running. In the public alpha release that we announced, there are really 5 kind of key things that are core of it, and we've demoed most of the things today. The asset inventory pieces, today we support 5 of the Google services in the asset inventory. The analysis, the pieces that have been used to allow you to find specific things, the marking part. What we didn't demo today are the kind of the notification piece that's built in to how you can use Command Center to generate a pub sub through a sidecar application, and also to directly trigger actions through Cloud Functions through a sidecar application. The Create Findings API that each of the 3 our customers and 2 partners have integrated with, and really, again, going back to that top goal, covering each of the 5 different things we're looking for from a security standpoint. The ecosystem is starting and continuously growing, and we're going to add more this quarter into the following quarters. And we're hoping that you folks in the audience, whether you're a direct customer who's writing findings, wants your own detectors, or have specific partners that you want integrated, come talk to us, and we can help prioritize that. So to learn more, we had the blog post back in March. All of our documentation is online and public. That includes the underlying documentation as well as the API guides. And so with that, I want to thank you guys. I want to invite the other speakers back up. And I think we have a few minutes for questions. But I also recognize that we're keeping you from drinks, so I'm certainly cool if you guys just want to call it a day. But thank you guys.